Okay, so where is? All right, so we're getting ready to start on your homework. There's my pen. Will you close that door for me, please? And Johnny, will you open that window up more so we'll get more of a breeze in here? Thank you.
Are we going to pass it up or go over it?
What?
The homework, we're going to pass it up or go over it?
We're going over it right now. And then you're going to have some classwork that's going to be a grade, and you're going to have 4 points for homework that will be a grade that I will definitely take up. Okay? All right, so on that 14.20, where you have the situation 2 forward up. Get forward up. Y'all ever heard somebody say that?
Yeah, man.
Get forward up. Okay, so it says pyrotech. All right, so they're celebrating 4th of July, and it says this town has hired pyrotech to launch the fireworks from an 80-foot tower in the center of town. Rockets can be fired up with an initial upward velocity of 64 feet per second. All right, they use a function that estimates the rocket's height, so they give you that function, but we've done enough of these now to know if they told us the initial velocity was 64 and the tower was 80 feet high, that we could have come up with that equation on our own. In fact, tomorrow when you're taking your test, you're going to have to come up with that equation on your own. So you need to be paying attention, put your Chromebooks up, put your phones up. The only thing you should have out technology-wise is that old calculator at this moment. You should be taking notes, especially if you weren't here yesterday or any other day this week, because your test is tomorrow. You ready now? All right, so they've got a tower over here, and they're shooting off the fireworks. And they come up, go back down, and they hit the ground. Or the little sparkles hit the ground. If you want to close that a little bit, will that bother y'all? Just close it like halfway. Maybe that'll help. If not, I'll just move that paper. It's not a big deal. Doesn't matter. We can move it anyway. Alright, so you got your fireworks going on. And it says we have our equation here. We know that this tower is 80 feet tall. From here to here is 80. So what is that point right there? If you thought about this as like if we flip the axis, like a reverse axis, if this was the axis, that's the X and the Y, and pretend like that's the positive part. I mean, I could draw the tower on the other side. Would that make you feel better, or are we okay with this?
I'm okay.
Everybody's okay if we just use this and pretend like these are positives over here instead of negatives like they really are? So what is that point right there? If that's on the y-axis, what is that point? Like what is that XY is what I'm asking. A point is an X and a Y. So what is that point? 0, 80. Because that's a y-intercept. That point is 0, 80, right? I mean, it's a y-intercept. It's on the y-axis. That's our C, our starting point there. They gave us that. They gave us that 64. So when we type this in here, there's a lot of things that they want. I still don't know how I got that calculator on here yesterday. So let me write in this table that they've got. In seconds, H is feet. I'm just trying to copy down what they have real quick. They came by 50, they came by $20. Okay, now I think I got everything they got. Right, so calculator. So we're going to type this one in. So we've got negative 16x squared plus 64. I put the negative. Plus 64x plus 80. So we're typing that in there. Everybody knows how to type. Everybody's typing, right? Everybody's got their calculator open. Everybody's putting it in their calculator. Just so we will tell Samuel, Emma, Zach, how much are those calculators if you break, lose, or anything else?
140.
140 bucks. So the moral of the story,
Don't break
Don't break them. Don't lose them. Okay, you gotta turn them in at the end of the semester, so. And you need to thank Mr. Shields anytime you see him, because he spent about $9,000 buying calculators for the Math 1 classes only, are the only classes that have the calculators. Everybody else just has to use what we've been doing the rest of the semester. Plus, if you're in science classes, you got new science calculators for your classes. All right, so we got this in here. Everybody got that? We're good? All right, I'm just going to hit Zoom 6 just to give us some practice in moving this thing around. That's definitely not what I want to see, is it? Now, they gave us a graph, and they gave you a graph on your paper for you to go by and look at. So your X minimum and X maximum are on here. Your Y minimum, Y maximum are on here. They told you they're counting by 1s on the X axis, by 25s on the Y axis. So let's make our graph look like theirs. So we're going to go to the window. Remember, we want to see a little bit below the minimum, correct? Okay, so let's go to negative 2. We'll say negative 2. I don't know. The maximum that they want to go to is 5, so let's go a little bit beyond that. Let's just say 7. And we were counting by 1s. The Y minimum, they were counting by 25, so let's just say negative 25. The Y maximum they have is 150. Let's go a little bit above that, so 175. And they were counting by 25s. Does anybody have any questions about what each one of these functions does from X minimum to the Y scale? Because on your test, and you're going to see it on what your homework looks like tonight, you're going to have to tell me what these things are. So the minimum, X minimum, X maximum, how far left, how far right, what you're counting by, the X scale, Y min, Y max, how far down, how far up, Y scale, what are you counting by? So is everybody good with that? I don't really care about anything from the resolution down. Just those 6 things right there. So does anybody have any questions on that, or what they mean, or what you think they mean, what they're supposed to mean? We're good? Okay. So hit graph. And there's hopefully what you have on your graph already. Okay? So they ask us to put points in there for 0 through 5. So if you were just starting this off, you would go to second table. There's your 0 through 5. Put those numbers in. What do you notice about the numbers? Starting from 0 going to 5. There's a pattern. They go up, they hit a high point, and then they go back down, don't they? And the numbers, if you notice, 144, 128, 80, they kind of mirror each other. That won't always happen. It just so happens when they do these types of problems that it's going to. So on your table, you should have filled out 80, 128, 144, 128, 4 is 80, and then 5 is 0. That's what your table should have in it right now. Any questions on that one? I mean, we're not through with the problem, but just so far, what we've done. Everybody's good so far? All right, so if I graph these, give me a different point, so 0, 80, you kind of, you have to guesstimate on some of these. 1, 128, 2, 144, 3, 128, 4, and 5. All right, so fireworks are shot off. They reach a high point, and then the debris falls back down and hits the ground. So we just labeled that point. That one was 0, 80. That was our y-intercept. What is this point, the x-intercept? These are important things on the graph, which is why I'm highlighting it. What is that point? 50. It's right here in our table. 50, which is also called an x-intercept, or a root, or a 0, or a solution. All those different things I could ask. So that point is 50. What does it represent, though, in terms of this problem? What 5 what and 0 what? If I said, write me a sentence describing 50, what would you say? That it hit what now? Say it a little bit louder. That the debris hits the ground. It's at 0 feet after 5 seconds. So 5 seconds after those fireworks are shot off, the debris from the fireworks hits the ground. Okay, what does 080 represent? If I said write a sentence telling me what that represents. It wasn't shot off yet, but what does the 80 represent? Which is 80 feet. So the fireworks are shot off at 80 feet. What does the maximum, that vertex, represent? The highest point that the fireworks reach, right? Okay, what is that maximum? We haven't really calculated technically, so let's go through how to find the maximum, because you're going to have to do this on your test. So you first got to decide, is a maximum or a minimum? And I hope by now you know this is the highest point, so it is a maximum. So we're going to do second, calculate, second trace, do the maximum, number 4. And we've got to take our cursor and go to the left of it. So we go left. Remember, you don't have to be exact. You want to be as close as you can. Go right. Calculator tells you at the bottom. All right, where are you going? Going right. Hit enter. Okay, are you ready to guess? Hit enter. So, do we have that point? Remember, that means 2. That rounds to 2. 1.9999977. 144. Do we have that point on our graph already? Yeah, we had that point in our table right here. So this is our maximum. So if I said, explain to me what 2 comma 144 means. Explain in one sentence what that means. What would you say?
That was the highest point that the fireworks reached.
And if you, did right here what Hannah said? That was the highest points the fireworks reached, which is correct. But if that were the answer I was given, I'm going to say, be more specific.
At 2 seconds, it reached 150 feet.
Okay, so here's what Kel said to add to what Hannah said. After 2 seconds, or at 2 seconds, the fireworks reach a maximum of 144 feet. Everybody understand that? So if I give you something like this tomorrow and say, explain this point in a sentence, I'm looking for it. Use these numbers. Use the units. Not the maximum is 2/144. I want to hear after 2 seconds, or at 2 seconds, the fireworks, or whatever we're talking about, reach a maximum of 144 feet. We good on that? Okay. All right, so number 1, how long will it take for the rocket to reach the highest point? 2 seconds. We just answered that. So you had to find the maximum. It'll take it 2 seconds. Number 2, how high will the rocket go? 144 feet. That's the maximum. Key point on the graph. You've got to remember, y-intercepts, maximum, x-intercepts. Key points on this graph. Number 3, how long after the launch will the rocket debris hit the ground? 5 seconds. That's simple. And all we had to do, type in the calculator or the equation, found the maximum just in case that we didn't have it in our table, elaborate on what the maximum meant and what the x-intercept meant. That was it. So any questions on that one? All right, number 5, it says a shot put champion releases the shot from 6 foot above the ground. The path of the shot is modeled by, so they give you an equation. So they say, okay, the equation is negative 0.02 d squared plus 1.1 d plus c. Now, this is a little different. We're not talking about time. Up in the top in those directions, they say d is the horizontal distance, so how far out the shot goes. H is the vertical distance. So this time our points, what we normally think of an x, y, are going to be d and h. Horizontal distance, vertical distance. So you got to understand what you're working with here. So we type that in our calculator. Let's see, go to y equals, clear it out. So negative 0.02 x squared plus 1.1x. What was it? Plus c. What was the initial height? How high was he when he shot the shot put?
6 feet.
6 feet. Through the shot put, whatever you want to say. Plus 6 feet. So that's your equation. You're typing in there. I have no idea. I'm just going to hit graph just to see what it looks like. That's really not what I want to see, is it?
No.
Okay, so I'm going to come back. I know I've got to see way more of this x-axis. Because basically what this parabola has happened is it's stretched out. It's like taking a rubber band, it's stretched out as far as it can go. So I need to see a whole lot more of the x. What about the y's? You think I need to see more of the y's?
No.
Not really, so I can take off some of these y's. But remember, we were counting by 25s in that last problem. So I'm just going to go to zoom 6 just to see what it looks like. I'm going to go back to that standard window. Now on this, I'm okay. I don't need to see all this negative part, because you can't throw it a negative distance. You can throw it backwards, but that's still throwing it. I don't really need to see the bottom, because you can't throw it underground. But I do need to see more, a whole lot more of the x, a whole lot more of the y. So I'm going to go in and adjust my window. Do I need to see the negative 10? No. So I'm just going to put that at negative 1. What do you think about x maximum? Throw in a shot put, a horizontal distance. Would 100 take it into account? Slade, do you throw the shot?
No.
Have any idea what they throw the shot at?
60.
60, okay, so we'll say 60. We'll just, we want to go past where they throw it, so let's just leave it at 60 and see. Let's don't count by ones though, let's count by twos maybe. Alright, how do we need to see negative vertical distance? You can't throw it down, so we don't need to see that, so let's just make that negative 1. Y maximum, how high do you think that shot's going to be thrown? How much? 16? Is that what you said?
I said 10, but I guess 16.
Well, I'm at 10 right now. You want to try 30 just to see? I mean, it's just a guessing game. It doesn't have to be perfect. Let's count by twos, though. All right, let's see what that looks like. Oh, we did a pretty good job. We still need to see a little bit more out this way, though, don't we? We can see the top of it, but we need to see more of the x. So I'm going to make that x maximum 70, let's say. See what that gives us. All right, so we're pretty good there. We can see it. Doesn't have to be perfect, but we can see it. All right, so what does it say? How far does the shot travel before it hits the ground? So the first thing you've got to know once you type it in, it's great. Well, any nincompoop can type in an equation and look at it. But what is it asking you for? What key point is it asking you for? Is it asking you for a y-intercept? Is it asking you for a maximum? Is it asking you for an x-intercept? Is it asking for a certain x value? In this case, it says, all right, how far does it travel before it hits the ground? So we're looking for this point right here. Now remember, what do we have to have in order to intersect that, though? We got to have y equals 0. So always make sure you got y equals 0, because if you don't put y equals 0 in there, the calculator won't let you intersect it. So you got to make sure you put that y equals 0 in there. Now we want to intersect it, so we go to second, calculate, and intersect, number 5. Number 5. So it's got to move your cursor down there to where the intersection point is. Oops. Alright, so that's close enough. And then just hit enter 3 times. And there's our intersection point. 60, 0. And now we've got to decide, what does that mean? 60, 0. So that x-intercept was 60, 0, but that's 60 what? So it goes 60 feet when it hits the ground. Okay, so how far did it go? 60 feet. Got to put the units on there. All right, number 6. A football player kicks the football from... So, Aaliyah, do you do shot put?
I did.
You don't do any more? Nobody does shot?
I do.
You do shot? All right, so you could use an equation to figure out the best way for you to get the maximum distance. Of course, you would have to be throwing it at 1.1, which is the initial velocity. If you think people don't use stuff like this, think about it in the Olympics or in college. When they're trying to maximize their distance or their length or their whatever they're doing things like this. It's a real life use for the quadratics. All right, so next one. A football player kicks the football from 2 feet above the ground. So he's probably punting the ball, I would say, maybe. Definitely not kicking off, could be on the tee. The path of the ball is modeled by, so they give you this equation. Oh, I hope you're paying attention and not waiting to watch the video tonight. Why waste your time doing that when you could be paying attention now? They say plus C. What is C though? 2 feet, that initial height. So that one's 2. Alright, so let's just type that one in there. So negative 0.015x squared plus 1.8x plus 2. I'm just going to hit graph because I have no idea what it's going to look like. I definitely need to see more of the x and more of the y, don't I? Alright, so let's see. More of the x. Now my x maximum right now is 70. I wasn't even close to the top, so I'm just going to double that just to guess at it. So I'm going to say 140. I don't want to count by 2, so I'm probably just going to change that to tens maybe. Y max, probably going to at least double that one just to see what it's doing. I have no idea, but I really think that they're going to kick it higher than 60 feet maybe. I don't know. So I'm going to take that one to tens too. Just kind of guessing just to see what it looks like. Oh man, I did a pretty good job. Yay for me. Everybody else get that or get something like it? It doesn't really matter what it looks like as long as you can see where it started, the maximum, and where it ended. What it looks like in between there, totally up to you. You can change your window however you want. As long as you can see that whole parabola, you're good. So what is it asking for? If the ball is not caught, how far does it travel before hitting the ground? So if the ball is not caught, so nobody catches it, they don't do a fair catch. So Reed, you return punts, don't you? Okay, so Reed doesn't catch the ball. He lets it go. He probably gets a good couple little nice words from his coaches if he don't catch it, maybe. Especially if it rolls and rolls and rolls on down. You ever been in that position?
Yeah.
You want to go out there and do it? Okay then.
I do.
Alright, so the ball hits the ground here. So it's not caught and the ball hits the ground. Assuming the ball's not rolling off anywhere, okay? So, we're looking for what again? The intercept. Okay. So let's do second, calculate intersect, assuming we've already got y equals 0 in there. And again, you should be doing this along with us. Watching doesn't mean you're learning. It is one part of it. But there's different facets. Hope you're not leaning your chair back. Enter 3 times. I got 121.10. Y'all get something like that? 120? Something close to it? Okay, so if this were a problem on a test, you would say 121, approximately 121 feet. Now, what if I were a football coach and I was trying to decide, well, instead of kicking it higher this way, what if I wanted it to have a lower trajectory? Would it go further if I kicked it at a lower angle? Yeah, okay, so if I was trying to find how high they were doing this or how high they were kicking it now, and it can be modeled, there are things, you might have used them in your science classes, they're called CBRs, calculator based range, I think it's called a ranger, that you can hold, it's like a motion sensor actually. Has anybody ever used one? You don't use one in science classes or anything? You probably did at Tri-County a little bit. Anyway, they're kind of cool though. I mean, you can, it's kind of like a radar gun, kind of, in a way. You aim the sensor at whatever it's doing and it will track it and graph it for you. It's pretty cool actually. But if I were a coach and I wanted to say, okay, no, I need to teach who punt. Do you punt, Slade? Well, you're punting today. Alright, so if Slade's punting, he's kicking it too high, and I'm like, no dude, you gotta kick it out further. You gotta have, this is the angle you're kicking at. You gotta kick it lower. You gotta kick it at a lower angle, and then it's gonna go further. That makes sense, doesn't it? If I don't waste all my energy going up, and I get my energy going this way, do you not think it's gonna go further? Yeah, it's gonna go further, I promise you. Laws of physics, yes.
know what you're saying, but when you're punting, it's supposed to go high.
Yeah, I get it. Oh, I'm thinking more like kickoffs or something.
Yeah.
And it's a different situation, like if you're kicking from your own 10 versus kicking from, or kicking from their, whatever, 40 or something. You know, it's different that way. What Reed's saying is you want to kick it high. Why do you want to kick it high? To let all your people get down there to provide coverage. Or to tackle the punt returner or whatever. But when you are punting, you want to kick it high, because if you get a low kick, some little squid kick come down through here, then the guy gets the ball faster and your people aren't down the field. But kind of just go with me on this. If you're trying to figure out you want them to kick it further, you've got to change that trajectory. So I'm just trying to give you ideas of this actually has real world uses besides just the school, the state is requiring you to learn how to do this. Different things that you do with this. And there's lots of different examples. We just don't have time to go over all of them. Okay, so we got 121 feet. So if I said, how high did you kick that ball? What would you find there? If I found the maximum, so let's do the maximum just to see, because I'm curious how high that ball is kicked. So if I do the maximum, let me come back up. Okay, so on the left, on the right, enter. So there's the maximum. It looks like 60, 56. Now here is my question of 60, 56. So that's the maximum. But what does that mean? How high did it go? Did it go 60 feet or did it go 56 feet? How many say 60? How many say 56? Okay, we got to look back at our variables. What does it say up above number 6? H is the approximate height in feet. That means vertical height. D is the horizontal distance. So if this is D, horizontal distance, this is height, vertical height, how high did it get? Let me say this again. D, which is X, H, which is Y, how high did it get? 56. How far did it go? 60 feet. Okay? Lord have mercy, gentlemen. Okay, now, I told you you're going to have classwork and you're going to have... What did I do with... Oh, shoot. I bet I left it up there. Oh, there it is. I don't put it in my paper. All right, now, 2 things. I'm going to go ahead and give you this. So this is your homework. And remember I said if you can kind of see this, I've got a problem up here. And then I've got a little place for you to show work, and over on the side it says X min, X max, X scale, Y min, Y max, Y scale. That's kind of what I'm talking about that I'm going to ask you for today. So this paper is homework, but you might get through with it in time to do it today during class, okay? So I'm going to go ahead and give you that first. Then I'm going to explain what we're doing the rest of class. No, I just wanted to go over that. There's so many of those other problems, and look at all those other problems we haven't gone over. We just haven't had time for all these 1-hour delays and 2-hour delays and everything else. Do what? Has everybody got one now? All right, go ahead and put your name on that one. Make sure you've got today's date, 3:30. Let's see, so who's not here? Shelby and...
Sylvia's driving.
Yeah, she's driving. She told me. She said, I will be here after school again today till about 3:45. Shelby and then Christy. Shelby and Christy. Today's Today's 30. Today's 30. Okay, now, look around the room and you see all these yellow sheets of paper. You've done something like this before. We're going to work on this again, and here's what you're going to do. 2, 4, 6, 8, 12. So there's an odd number. All right, here's what we're going to do. You are going to... You're together, you're together, you're together. You're together, you're together. You're together. You're together. Let's do... Come back to this table. You 3 are in a group together. You're going to be my group of 3. Okay? And then you 2 and you 2 are together. Okay? So now right here, you 2, you 2, you 2, you 2. Okay? Everybody know who they're with? All right, now here's what you're going to do. You are going to have one sheet of paper, and it looks like this, between you. All right, you're going to have one sheet of paper. It says projectile motion scavenger hunt. These are word problems, just like what you've been doing. Now remember on our scavenger hunts, you start anywhere you want to, answer the problem, find your answer on the next paper, correct? Okay, so you're going to do the exact same thing. Now, I've given you a lot of room to write your work here, but there's really, is there any work that we've been doing right here? No. But what I want in this box is the equation. Like if I were doing this one right here, if I started here, I would write this equation in that box. First thing, write the equation in the box. So that equation, everybody say that equation. I'm going to write that equation in that box. Now, then I'm going to answer my question, whatever. This one says, what's the maximum height that Maria will reach? So me and my partner, we're going to put that in our calculator. We're going to find the maximum height. That answer is going to go over here in this little box. Everybody got that? You'll find that answer somewhere around the room, go to that one, and then remember it loops all the way back around. So are we good? Right, this is a grade. This is a classwork grade between you and your partner. Class ends at 11:40. That means you have how much time?
36 minutes.
My clock's a little slow, so it's about 35, 36, 37 minutes to do these problems. There's only 10. You should have ample time to get these done. This is due before you leave. If you get through this, and honestly, it shouldn't take you maybe 20 minutes to do this. You got to get good. And I do not want to see only one person working. If you are the strong person in the group, please help the other person. If you are the weaker math student in the group, please ask questions from the other person. Maybe you're the same. Help each other out. We got to learn. We have to learn from each other. We got to learn to ask questions. Okay? Any questions? Any questions? No questions? Okay. One person, I'm going to put these up here on the board or on the table.